Hello learners, welcome to this course on Embedded System Design using PIC16F877 microcontroller. In this tutorial, I will be discussing about on how to configure and program external interrupts in PIC16F877 microcontroller. So an interrupt is a signal generated by a hardware or a software. So the hardware can be any peripheral devices. Either it can be an internal peripheral device or an external peripheral device. So a signal is generated by the hardware or software when a process or an event requires an immediate action or attention. So when the signal is generated, the CPU will try to execute the program related to that hardware or a software. So the peripherals tries to make use of the CPU for doing certain actions. So that is what we call it as an interrupt. So the interrupts, as I said, in hardware mode, it can be due to internal peripherals or external peripherals. Internal peripherals in the sense, we have many peripherals inside the microcontroller itself, like ADC, timers or counters, UART, SPI protocol, I2C protocol. In few microcontrollers, we have comparators also. So in PIC16F877, we don't have a comparator, whereas we have other peripherals inside. We can also connect external peripherals like switch, keypad, keyboard, joystick, mouse, etc. So whenever I press a switch on a keyboard, so that can be used as an interrupt signal to the CPU. Once a keyboard key press is obtained as a key press, as an interrupt, the CPU will try to execute a program related to that keyboard. So thereby it identifies whether it is a valid key press and it tries to recognize what key has been pressed, whether it is a key A, B or numbers, whether it is which key is pressed. And depending upon the application, the recognized key can be sent to a Word or Notepad, etc. So we have in hardware two types of interrupts generated by either internal peripherals or external peripherals. Similarly, we can also have a software-based interrupt. Something like if I divide a number by 0, which can generate an interrupt. If there is an illegal memory access, then it can generate an interrupt. If there is some problem with the data bus, then it can also generate an interrupt. So like that, we can have a software-based interrupt too. So here in this tutorial, I am going to discuss about the external interrupt. So we are in PIC16F877 microcontroller. We have only one pin where I can connect the external peripherals and it can generate an interrupt. So the pin is RB0/INT. INT stands for external interrupt pin. So this external peripheral which is connected to this pin can generate an interrupt to the microcontroller. And there is also internal peripherals which can generate the interrupts. In the next slide, I will show what are all the different ways by which an interrupt can be generated. So if a microcontroller receives the interrupt signal from multiple devices tries to use the CPU at the same time, then we can also have an interrupt controller, and this interrupt controller can work based upon the priority. And depending upon the priority, a particular interrupt can be serviced by the CPU. So what happens when an interrupt occurs? Let us take a CPU is doing some program execution. So it is executing this code, instruction 1, instruction 2, instruction 3, instruction 4. So while performing instruction 4, let us assume an interrupt has occurred. So first the CPU, what it will do? It will complete the instruction execution. So instruction 4 will get executed first. Upon completion of that instruction 4, now the program gets transferred to the interrupt service routine. So the program related to the interrupt. So before moving on to this interrupt service routine, the context of the main program will be saved in the stack memory. What is context? The associated registers with the main program, the program counter value, everything will be saved on the stack memory. then the program control will be transferred to the ISR, interrupt service routine. Upon completion of the interrupt service routine, the context which is saved in the stack memory will be retrieved back. It will come back to its original location. It will come back to the program counter value, registers associated with it, and then the main program continues with instruction 5, instruction 6, instruction 7 and instruction 8. So thereby whenever a peripheral needs to use the CPU, it will make a request. At the time alone, the CPU will try to execute the program related to it. During the other times, the CPU will do its original program, or whatever the program it is working on, it will try to carry out the program. So this is the interrupt mechanism workflow. So there are different interrupts supported by your PIC microcontroller. Here you see lot of peripherals like EEPROM, oscillator, A to D converter, USART, MSSP modules, CCP modules, timer modules, comparator modules, timer 0, port B change interrupt. So here in this tutorial I am talking about this RB0 INT pin. So where I can connect an external peripheral. So in this case, if you see, all these peripherals can generate an interrupt, and all these interrupts goes through a common line to the CPU. So here all the interrupts comes through a common line. Okay, we don't have separate lines for each and every peripheral devices. All the interrupts are going to communicate to the CPU through a common line. Then how a CPU can differentiate whether the interrupt is from EEPROM or whether the interrupt is from port B change interrupt or it is from timers, how it can differentiate? By looking at the flag registers. You can see each and every peripherals as a flag register associated with it. So EEIF flag, which is EEPROM interrupt flag, oscillator interrupt flag, A to D converter interrupt flag. So like that you can see for external interrupt also I have external interrupt flag. So by looking at this interrupt flag, the CPU can recognize it, which interrupt has occurred. So once an interrupt signal is received by the CPU will try to check the flags. So if this external interrupt flag is activated, then it will identify, okay, external interrupt has occurred, then it will try to execute the program related to the external interrupt. So whenever an interrupt is being generated by a peripheral device, automatically the interrupt flag will be set. So in order for this signal to get communicated to a CPU, what we have to do, we have two control switches. For external interrupt to get communicated to your CPU, I should enable the external interrupt and also I should enable the global interrupt. So INTE is for external interrupt enable, GIE is for global interrupt enable. So if these two switches are being configured, then only the external interrupt can reach the CPU. Otherwise, it will be stopped. Same way, if I take some other interrupt like timer 1 interrupt, if the timer 1 interrupt should be communicated to the CPU, then I should have timer 1 interrupt enable to be configured, peripheral interrupt enable should be configured, and also global interrupt should be configured. Then only the timer 1 interrupt can be communicated to the CPU. So accordingly, the configuration of the registers should be done. Thereby, the interrupts can go to the CPU, then the CPU can execute the program related to that interrupt. So now in this tutorial, we are talking about external interrupt. For external interrupt to be communicated, I should configure INTE, which is external interrupt enable, and global interrupt enable. Then only the signal from the peripheral can go and reach your CPU as an interrupt signal. So how to configure this? External interrupt enable and GIE. We have registers associated for configuring it. First register which we are going to talk about is INTCON register, interrupt control register. In that you can see the bit GIE is nothing but global interrupt enable, which is this line, global interrupt enable. So this I have to set it to 1. Then only this signal coming here, it can go to your CPU. And then I need to configure this INTE also. So INTE is also available in the INTCON register. You can see bit 4. Bit 4 is a INTE signal. So I have to put 1 for GIE and also one for INTE, so that the external interrupt can get communicated to your CPU. Then you can also look at the INTF flag, which is available in bit 1 of your intercon register. So this is the flag register. Whenever a peripheral generates an interrupt, it will set this flag. So as a programmer, we have to reset it. Whenever the peripheral wants to use the CPU, it will set it. So once the interrupt service routine is being serviced, this needs to be reset. So you make use of these 3 lines: GIE bit number 7, INTE bit number 4, and INTF bit number 1 for our external interrupt. There is one more register associated with the external interrupt, which is option register. In option register, I have bit number 6, which is INT edge, whether my interrupt should occur on rising edge or falling edge. If I put INT edge to be 1, then interrupt occurrence will be during rising edge. 0 means it will be during falling edge. Rising edge means the voltage will vary from 0 to 5 volt. Falling edge means 5 volt to 0 volt, it will make a transition. So INT edge will be used for configuring our type of interrupt, whether it is a rising edge interrupt or falling edge interrupt. So these 2 registers are used for our external interrupt configuration. In intercon register, we have 3 bits: global interrupt enable, external interrupt enable, and external interrupt flag. And in option register, we make use of only 1 bit, bit 6, which is INT edge. So in this tutorial, I am going to discuss about how to use this interrupt for toggling of your LEDs. So I am going to connect a switch to the interrupt pin RB0 INT pin. Whenever I press a switch, it will go to a ISR, it will execute a ISR. When the switch is not pressed, the CPU will continue its main program. So here I connect LED to port C from RC0 to RC7. So CPU will try to run a program in a default state. Whenever a switch is pressed, the CPU will go to the ISR interrupt service routine and it will execute a program. Thereby a change in logic of the LED can be observed. So for this, we'll be making use of a micro C Pro for PIC environment as IDE, where we'll be writing our program, converting this program into a hexadecimal file. We will be building the circuit and simulating the circuit using Proteus 8 Professional. So we can configure our external interrupt either in rising mode or in a falling mode. For this program, I'm going to use it in a rising mode. So a few things you have to remember while declaring your interrupt service routine. A delay function will not work in the interrupt service routine. So we can't use a delay function there. And whatever variables we declare in ISR should be declared as a volatile variable. And when an interrupt service routine is being executed, whatever data we receive through serial communication will be lost. So these things we should remember while working with the ISR. So now let us go to the Proteus 8 Professional to build the circuit. So let us create a new project. Select a location for the project. Select a name for the project. So select a location, select a name for the project, select a default schematic. We are not going to create a PCB layout. No firmware is used. Press next. So only schematic is selected. Press finish. So this is the location where we are going to build the circuit. First, let us select all the components required. Go to PIC device, PIC16F877. Add it to your list. I require a crystal. Similarly, select all the components required. Capacitor, switch, resistor, bar graph LED. So I will take a red color LED. So these are all the components which I require. Once I select all the components, press OK. Now use these components to build the circuit. First let me select the microcontroller, place it onto the circuit. So connect the crystal to the circuit. Connect to pin number 13 and pin number 14. Connect the capacitor to the crystal so that a stable frequency will be generated. Set a value of 33 picofarad to the capacitors. Connect the other end of the capacitor to ground. For selecting the value, right click the component, edit properties, select the value, edit properties, select a crystal frequency. So I am going to use a 10 megahertz crystal. So set this as 10 megahertz. So this completes the oscillator circuit. Next we have to connect the reset circuit. Again go to components mode. Select a switch, place it onto your circuit, resistor, connect one end of the resistor with the switch, other end of the resistor to the supply. Go to terminals mode, select the power, connect it to the resistor. Other end of the switch, I connect it to ground. And the intermediate point between resistor and the switch will be connected to your memory clear pin. So you can see the memory clear is an active low signal. So by default this pin will be at logic high. Whenever I close the switch, this pin will go to logic 0, thereby reset operation will take care. Next one is I am going to connect a switch to RB0. So for connecting a switch, again go to components mode, take a switch, connect it to your RB0. Other end of the switch, I need to connect it to supply. Go to terminals mode, select power. So I also need to connect the resistor here. Select the resistor, put it onto your circuit. Other end of the resistor, I am going to connect the ground. So what happens? By default, the RB0 external interrupt pin will be at logic 0. Whenever I close the switch, the supply will be provided to the RB0 INT pin. So thereby, my interrupt signal will be a rising edge signal. So by default, 0 will be there. Whenever I close a switch, it goes from 0 to 5 volt. It's a rising edge signal. So now let me connect the bar graph LED to port C. So I am going to connect bar graph LED to port C. So I am going to connect 8 LEDs to port C. Anode of 8 LEDs are connected to RC0 to RC7. And the cathodes, I need to connect it to ground. Select the ground, place it onto the circuit, connect it to the cathodes. Okay, so I have connected the cathodes to ground. So this completes the circuit. So we have put the oscillator circuit, reset circuit, then external interrupt. I am going to use a switch for generating the external interrupt, and we have connected a bar graph LED to port C. So let me save the circuit. Now let us go and build the program in micro C. So in micro C, create a new project. Next, select a location for your project, give a name for the project. Select the device for which we are going to work on and select the oscillator frequency. So I'm going to use 10 megahertz. So 4 things which you are doing: select a location for the project, give a name for the project, give a device name as well as the oscillator frequency. Press next. We don't have files right now. Press finish. So this is the location where we are going to put our code. So let me save this with the extension of .c, external_int.c. Let me take the program. Put it in. So here you see, I have void main, and tris_b I have defined it as 0x01, which means I have 0, 0, 0, 0, 0, 0, 0, 1. So RB0, so this is RB0 line, which I have connected a switch in our circuit. So which means I need to configure it as an input pin. So I use a data direction register. tris_b is a data direction register for port B. So if I put a value of 1, the corresponding pin will be configured as input. If I put a value of 0, then the pin will be configured as output. Since we have connected a switch to RB0 pin, I have set it as 1. So tris_b equal to 0x01. In case of tris_c, I have connected the LEDs. So I am going to configure all the port lines as output lines. So 0 means it will be configured as output, 1 means it will be configured as input. Then I am going to use a intcon register, which is an interrupt control register. So which is nothing but 90. So 90 stands for 1, 0, 0, 1, 0, 0, 0, 0. So here this one stands for GAE and this one stands for INTE. You can look at this. So GAE 1 and INTE 1 and INTF is set to 0. So 1, 0, 0, 1, 0, 0, 0, 0. So global interrupt enable we have set, and INTE also we have set, INTF we have put to 0. Same way, we set the option register to be C0. C0 means 1, 1, 0, 0, 0, 0, 0, 0. So here I set this bit 1. So this 1 represents the INT edge bit. You can look at 1, 1. So INT edge I have set it to be 1, which is nothing but the rising edge. So rising edge will cause the interrupt. Rising edge will cause the interrupt. So that is what we do here. So this completes the configuration part, and in the while loop I am going to switch on all the LEDs for 1 second and switch off all the LEDs for 1 second. So this is going to run continuously in the main program. So when an interrupt occurs, then the CPU needs to execute the ISR. So the ISR is given by this program, void interrupt. Void interrupt is a keyword which indicates it is for external interrupt. So in the interrupt, first thing what the CPU will do is whether it is due to external interrupt. So that is checked using intcon. I have a bit called as INTF. The CPU will check whether this INTF bit is equal to 1. If it is equal to 1 means the interrupt is caused by the external interrupt. Then what it will do, we are going to change the logic. Port C is equal to 0xAA, which means alternate LEDs will glow. So AA stands for 1, 0, 1, 0, 1, 0, 1, 0. So which means 1 positioned LEDs will glow, 0 positioned LEDs will be in off state. It will be in this logic for 1 second, then after 1 second it will go to 0x55, which means 0, 1 0 1 0 1 0 1. So the LEDs which were in on state will go to off, off state LEDs will come to on. So in the interrupt service routine, this happens. So after completing the ISR, we again reset the INTF flag because further interrupt should be recognized. So the INTF flag will be set by the hardware. After completing the ISR, the INTF flag should be reset. So we reset the flag and come out of the ISR. Again the CPU will try to execute the main program. Again whenever there is a switch press, it will go to the ISR, it will check whether the interrupt is due to external interrupt, and then it will try to do this logic. Once it completes the logic, it will again come back to the main program. So thereby an external interrupt can be addressed. So let us save the program. Let us build the circuit. So there are no errors. Now let us go and import this hexadecimal file onto the circuit. So right click the microcontroller, edit properties, select the program file. External interrupt. Then select the processor clock frequency. We have set it to 10 MHz. So I have set it to 10 MHz. Press OK. So now we have imported the X file into the microcontroller. Now let us run the program. When I run the program, you can visualize all the LEDs are glowing for 1 second and it is off for 1 second. So right now it is executing the main program. Now when I press the switch, the RB0 INT pin will go from 0 to 5. Thereby interrupt will occur. Then there will be a change in the logic from AA to 55. So when you see, when I close the switch, it goes to AA for 1 second. It goes to 55. So after completing it, it comes back to the main program again because we are executing the logic only for once. Then again, when I release it, nothing will happen. Again, when I press it again the logic will go from 0 to 5 volt. So when it goes from 0 to 5 volt, again it goes into the ISR, it executes the program. After executing the program, it will come back to the main program. Now it has come back to the main program. So that is how an external interrupt can be serviced by the CPU. So in this tutorial, I have discussed about on how to configure the external interrupt and how to execute a program for the external interrupt. Thanks for watching. Please subscribe for more technical learning. Thank you.